So in this case question, we have a pendulum, a sphere, string of negligible mass. It is pulled back until it's horizontal. So it's brought up here like this. Now, first of all, we should be thinking, wow, craziness, because this angle is greater than 20 degrees, so it violates the small angle approximation. So we'd expect this thing not to obey simple harmonic motion or behave like a normal pendulum, if that's what the question's about. So we want to be on alert about that. So we assume the gravitational potential energy equals 0. So that means, anticipating where this is going from, there's this gravitational potential energy up here, and when it comes down, this will be, it'll be all kinetic energy. So if this is 10 joules, this will be 10 joules down here. What angle will the energy, the potential, and the kinetic be equal? Well, that angle, that will be when half the height. So this is h over 2, and this is h over 2, or L over 2, that length. So the question is, at what point does that happen? And what angle will it make with the horizontal? So we are talking about this angle here, this angle theta. And if you notice from this picture, it looks like it's going to be quite a bit less than 45 degrees. It's going to be quite a bit less than 45 degrees. And that's because you can see as you get in this latter half, the height isn't changing very much with every degree, whereas this is steeper and this is not as big a delta y, change in height. So we expect this angle to be less than 45 degrees. Less than 45 degrees. Now, we could actually calculate this. And the way we could do that would be to draw a right triangle like so. And this is the hypotenuse, which represents the length of the pendulum. And this is the length over 2. So the sine of theta would be L over 2 divided by L, which is L over 2 times 1 over L, which is 1/2. So what angle has a sine equal to 1/2? Well, that angle is 30 degrees. So again, that would be less than 45.